Hello students. In the last class, we had covered the two different problems, or we can say the two different cases. One was that what should be the minimum velocity that we should give to the bob or the particle so that it can complete the full circle. And here we had like calculated the minimum velocity, that was what, root 5 GL. And after that, guys, one more problem we had seen after that, that was that what should be the maximum velocity that we can give so that the particle never go in the upper half of the circular path. Okay, so these two problems we had covered, and then I had asked you that I will discuss one last kind of a problem, that was that if velocity is more than root 2 GL but less than what, root 5 GL. Okay, so this is the third case that we had to explore. So here, guys, if you see, the thing is, we know that if velocity is greater than root 2 GL, greater than greater than root 2 GL, then of course it will go it will go in the upper half. And as it will be less than root 5 GL, so it can't complete the full circle. So guys, the question comes that if, let's say, the velocity is falling in this category, what will happen? Okay, so let me show you the situation. Suppose, guys, this is your, let's say, the circle, and this is your center, and this is your particle which is attached to this string. And when we give the velocity, guys, what is going to happen here? It is going to come into the upper half. Okay, it is going to come in the upper half, that we know for sure, but it is not going to, what, guys, do the full circle. Now this is an interesting thing that we should observe here, that there are two types of possibilities that might come in our mind, that can happen here. Okay, what are those possibilities, guys? The first possibility is that maybe the particle will go up here and then velocity becomes zero or something like this. It will do, okay, this kind of a oscillation starts. Okay, this might be the possibility. To make it happen, guys, what should happen here? The velocity should be zero and the string should be what, tight, because if string slacks, then this circular path can't be achieved. Okay, so of course, means there are first condition, that the first possibility is, guys, what, first possibility is v should become zero and tension should not be equal to zero, and then what will happen? The particle will oscillate in this kind of a path. Okay, that could be the one possibility. The second possibility, guys, the second possibility is what, that possibility is what, guys, is that v not become zero, v will not become zero, rather the t becomes what, guys, zero. What does it mean? Means, guys, when the particle just reaches here, the tension becomes what, zero. Means there is no control by the string on the particle is there, and the particle can move as it wants to move. So suppose, guys, there is some velocity is left here to the particle, and due to this velocity the particle is going to do this kind of projectile motion, and then might be it will come here and then it will do the oscillation or something like this. Okay, so this could be another possibility, guys, that the velocity will be non-zero, and before before the velocity becomes zero, the tension becomes zero, and so that the particle like get free from the constraint of what, moving on a circular path, and due to the help of what, this velocity left, it will move like a what, a projectile, and then when it will go back to what, this position here, then what will happen, guys, when it will reach to this position, the string becomes tight again, and then it will come and do the what, oscillation. Okay, something like this that should happen. So let's check that, guys, what could be the possibility in this case. Okay, so it's very simple thing, guys, that we can see from here, that if you see the velocity, if we see at any point of time, will be how much, it will be under root of v naught square minus 2gl 1 minus cos theta. Okay, so guys, velocity is decreasing like this way, because if you see, as the theta is increasing, increasing theta is increasing, the v is going to decrease, okay, in the magnitude. Okay, this is going to happen. Now guys, if you see the tension is what, tension, if you see at any general point of time, will be what, guys, it will be mg cos theta plus mv square by L. This we have derived, okay, at any general point of time, if you remember, or I'll just show you so that you can see this thing. Okay, here guys, when we were discussing, we have derived this formula that when the this will go this side, okay guys, so it will become what, t is equal to t is equal to mg cos theta plus mv square by L. Okay, so that's why I directly wrote that. So guys, t is equal to what, mg cos theta plus mv square by L. Now if you see, guys, here the thing is that you should observe that because cos theta is a decreasing function, so this value is going to decrease. Okay, this value is going to decrease because mg cos theta is going to what, decrease, because theta is increasing. But along with that, guys, what, mv square by L is also what, going to decrease this tension. Okay, these two factors if you see, so what we can say, we can say that the rate of decrease of tension is more compared to rate of decrease of velocity. Why? Because if you see, guys, if here only the velocity and tension was correlated, okay, then we could say that yes, the tension and velocities are what, v naught square minus 2gl 1 minus cos theta, so they are directly what, decreasing with the what, same rate. Okay, okay, but here guys, if you see, because mg cos theta is also a factor which is what, added here in the mg cos theta, and it is also what, decreasing. So what we can say, the net rate of decrease of tension would be what, more compared to what, the velocity rate of decrease. Okay, so what we can conclude from here, that tension will become zero first first compared to the velocity. Okay, it means what, guys, that we will see that the string will become slack in the earlier. Okay, and velocity will be what, non-zero at that moment. Okay, what does it mean, guys? It means that if, let's say, if we have this circle, okay, and let's say this is your particle, okay, and we are throwing it with some velocity which is what, more than root 2gl and less than root 5gl, what is going to happen, guys? It will go, and as it will reach to some point where the tension becomes zero, the rope will what, guys, slack. There will be no tightness in the string, but at this moment velocity will not be zero, it will be what, guys, it will be non-zero. And due to this velocity, guys, the particle will move like a projectile. Okay, the particle will move like a projectile, and then it will come back something like this. Okay, so it might be an interesting problem, that what would be the range of this projectile, or maybe we what we can say, what would be the time of flight of this projectile. If you talk about the range, guys, the range would be what? Simply you can see the range would be nothing but what? This only, that is what? 2L. Okay, but if you want to talk about the time of flight, of course that is going to be what? A different thing that we should calculate. And if let's say somebody asks what is the maximum height, that is a different thing. Okay, so maximum height, time of flight, these all things we have to see if you want to calculate it. The parabolic path, if you see, this is something like this, I think so. The parabolic path would be okay. So but uh, nevertheless, these things we will explore in the part of the problem. Right now just I wanted to discuss this thing only, that yes, what would be the kind of motion the particle will behave or particle will perform when the velocity is what? More than root 2 gl and less than what, guys? Root 5 gl. So I hope you understood this thing, guys. Okay, now we have covered all sorts of possibilities, guys. Okay, that if I'll just summarize this, guys. If velocity is v naught is what, guys? If it is greater than 0, okay, or equal to 0 and less than root 2 gl, then it will, or equal to root 2 gl, then it will oscillate in the lower half of the circle, and at any moment tension will not be zero. Tension will not be zero, not be zero. Okay, only, guys, when can the tension be zero? When only velocity is given equal to root 2 gl, then at the verge of the lower half boundary, tension will be zero. Okay, and that we can see also, guys, if you just put this thing 3 mg cos theta minus 2 mg, you can do the qualitative analysis also. From that also you can see, guys, just for the like using math only I'm just showing you, guys. So t is equal to what? If you put 90-degree, guys, okay, so this will become what? This will become 0. Sorry, guys, this will become what? This will become 0. So 0 minus 2 mg, and if you put root 2 gl, guys, it will become what? 2 mg. Okay, so this and this, guys, so net will be what, guys? 0. So always remember, guys, if you give velocity equal to root 2 gl, then the tension will be what? Become 0 at the 90-degree angle. Okay, or you can say the verge of the what? The lower half of the boundary. Or you can say if velocity is less than root 2 gl and greater than 0, it will never be, guys, what? Tension is going to be 0. Okay, velocity could be 0 at the extreme, okay, up to which it can go, but tension is never going to be 0, guys. That is the first thing. Okay, second thing that I have concluded is, if velocity is, guys, what? If velocity is greater than root 2 gl and less than what, guys? Root 5 gl, then the particle will go in the upper half of the circle, upper upper half of the circle, and and tension becomes zero at some instant, and rope will slack rope will slack, and particle perform perform projectile motion, projectile motion, projectile motion. The range, I think guys, there I had mistaken. Okay, we had thought that the range would be what, 12, but that is not the case. Okay, the thing is, if you see, if you have thrown like this, okay, just see guys, if you thrown like this, okay, the particle will go like this. Okay, it might take this trajectory also, and it come like here. Okay, it might come it might come here guys, it might go here also. Okay, it depending on the angle and the velocity that we are having. Okay, but of course when wherever it goes, okay, it will follow a parabolic path. This possibility is also there, but guys, the thing that I had said at that point of time, that is wrong only. Okay, it go like this. Okay, and if you see, this could be a parabolic path. Okay, this could be a parabolic path, this could be a parabolic path. So the range we have to calculate at that case. Okay, if somebody asks that what would be the range, we have to calculate that thing at that moment. Okay, so we will see the problems guys, there it will become more and more clear. Okay, and now the last part guys was, if velocity is greater than or equal to root 5 gl, in this case, in this case particle will perform perform full circle. Okay guys, so these are the three possibilities that we could have, and we have seen all these three in detail. Okay, now coming to what guys, some other kind of the problem types. Okay, like guys, see, instead of the string, okay, instead of the string, if scenario 2, okay guys, scenario 2. So guys, what is this scenario 2 I want to talk about? It's very simple guys. If you see, if you have a trajectory like this guys, suppose, okay, I don't know what it will form, so it has formed something very bad. Let me uh, I'll make like this only guys. Okay, see guys, suppose this is a trajectory and there is a particle that you are dropping here guys. So here guys, if you see, the normal force, this is a vertical plane guys, it's like a roller coaster or something. So here guys, if you see, this block will perform the circular motion in this vertical path. Here guys, the normal force will, you can say, working as a what, as a surrogate of what, of the tension force that was there in the string. Okay, and it is also behaving like same only guys as the tension was behaving. So if velocity is what guys, let's say less than root 5 gl and greater than root 2 gl guys, what will happen, it will reach somewhere here and the velocity is remaining, and due to this velocity guys, it will maybe perform this kind of a projectile. Okay, this kind of a projectile it may perform. So what I want to try to say you guys, that if this vertical circular track, circular track comes as a problem statement, as a scenario problem scenario, the ideas and the relations that we have developed, that we have developed we have developed can be applied, can be applied as it is, just by replacing the tension force with the normal force. Okay guys, so that's simple. So if guys you see this kind of a scenario, you can use this like technique, or you can say the concept that we have discussed. And it is more like a what, the string plus block problem. Okay, here guys you have a vertical track, vertical circular track, and the normal force is helping you as a what, as a center, like providing you what, that centripetal force, okay, toward the center with the, of course, with the combination of mg force. Okay, but if you see, this combination n plus mg is way similar as what guys, t plus mg. Okay, where t is what, tension force. Okay, now guys, coming to the one last what, the scenario that I wanted to cover guys. So if you see guys, scenario 3. Okay, scenario 3, what it is guys, if you see, the thing is, if guys we have, if we have the, instead of a string plus block guys, if we have a rod, okay, let's say for ease guys, we are assuming it's a massless rod. Okay, it's a light rod, and there is a block like attached at the other end of the rod. Okay, and the other one end is what guys, you can say hinged. Okay, so guys, if we want to analyze that, what will happen in this case if we do the what, if we want that it should perform the projectile, like, sorry, the circular motion, what it will do guys. So here if you see, if we give guys what, if we want that it should do the circular motion, the concern is what guys, if anyhow, if anyhow it reaches on the topmost point, okay, and it, if it has a just a little bit velocity in the positive side, means if its velocity is what, 0.00001 or something like this. Okay, if that is the case guys, automatically, automatically guys, what will happen, due to the shape of the rod, or the, you can say the nature of the rod, that it is a solid thing, okay, and it is not going to get what, compressed or slack, this ball will automatically guys what, comes here. Okay, it will automatically what, comes here, and it will perform the full circle. So in this case guys, if somebody asks you that what should be the minimum velocity that we should give so that particle can do the full circle, is going to be a different story compared to what, string plus block problem. Okay, so guys, in this case what we should do, the concern is that when the particle reaches at the topmost point covering the pi angle as angular displacement, the velocity that is needed on the topmost point is what is 0. There should be no like non-zero value we need, we can take it approximately what, 0 value, and in that case the particle will automatically what, perform the full circular motion. So guys, in this case, because the math was what, very much same that we had covered earlier, so I can put the values directly, that v naught square minus 2gl 1 minus cos theta is equal to what, v square. If I put the value guys, so I want at the top most guys, velocity is what, 0, when theta is what, pi. So guys, if I put these values, what I'll get, v naught square is equal to 2gl 1 minus cos pi is what guys, minus 1. So it will become what, it will become 4gl. So guys, v naught that is needed is how much, 4gl only. So guys, if you see, in this case we don't need root 5gl velocity at the bottom of the particle. Instead of that, even with the root 4gl also we can make this happen, that the particle can perform the full circle. So guys, here the need of velocity is what, less. I hope you understood. Okay, now coming to the case 2. The case 2 is what guys, case 2 is in this, if we want, we want that particle oscillate only, particle oscillate only in the, in the lower half of the circle. Okay, this is the requirement that we are having guys. So this is also very easy. So if you see guys, if we want that it should not go in the upper half, it means guys when it reaches on the verge of what, this position here and here, the velocity should be what guys, 0. A velocity will become 0 automatically due to the gravity pull. It will what, it will come down. Okay, so guys it will oscillate in this part only. So guys here what we should do, we can take v should be 0 when theta is what, 90 degree. So guys it is very similar that the cases that we have discussed earlier. So but just for the sake of what, formally to describe this, I'm solving again. So v naught square minus 2gl 1 minus cos theta is equal to what, v square. So v square should be 0 when theta is what, pi by 2. So guys if I put this value, what I will get, v naught should be what guys, root 2 gl. So again guys, the same picture that we had seen earlier, because guys see, the string was not going to slack and rod is at all guys, it is not going to slack, it is going to maintain its shape. So guys what we can say, that string and the rod case is pretty much similar when we are just focusing on the what, lower half of the this circular motion. Okay, so guys here we not should be equal to what guys, root 2 gl if you want to just reach out of the what, the upper at the verge of the what guys, the lower half of the circle. So what we can say, that v naught should be less than or equal to what guys, root 2 gl, and greater than what, 0 or equal to 0, to stay in the what guys, lower half of the circle. Now the comes the interesting part guys, that case 3. Okay, and that is guys what, that what will happen, what will happen if v naught is less than what guys, root 4 gl, and it is greater than what, root 2 gl. I'm hoping that you have gotten the answer already, and let's just discuss this guys. So in this case guys, if you see the rod here, and guys we know that it will go in the what, it will go in the upper half of the circle. Okay, we know that, but guys what is going to do, like what it is going to do. So if you see guys here, what is going to happen, as the particle will come here. Okay, come here. Okay, what will happen guys, that actually tension becomes what guys, 0. Tension becomes what, 0. But because the tension becomes 0, the rod is not going to slack. Okay, so actually guys earlier what was the force, this was the force. Okay, this was the force, the tension becomes what, 0. But guys as the tension becomes 0, this velocity will be what, of course non-zero. But guys this rod, its nature is like this way, that it is not going to slack. So it is not going to allow the particle to go what, to do projectile, of course. Okay, so what is going to happen guys is very interesting. Okay, so what will happen, the particle will go a little further. Okay, particle will go guys what, a little further, and here guys what will happen, the compression would be getting developed in the rod. Okay, the compression is going to be getting developed into the rod guys. Here let's say this is some theta naught guys, when the tension becomes what, 0. And after this guys what will happen, here the tension becomes what guys, 0. And after that guys the compression is going to get developed, and this compression will be what guys, you can say it is towards the what, towards the particle direction, or you can say the radially outward direction. And guys it will keep acting on the particle up to when the velocity becomes what guys, 0. Okay, up to when the velocity becomes what guys, 0. And after that what will happen, because the velocity becomes 0 guys, now there is no chance that it can go up to the topmost height guys. What it will do, I hope you got the point guys, it will come back due to the pull of the gravity. And now guys it will do this kind of motion. Okay, it will do what guys, this kind of motion, and that is very interesting. Okay, if you see, so this kind of a motion can be performed guys if it is a what, a rod plus a block combination. And the velocity should be what, guys, less than root 4 gl. So guys, here what happened here, if you see the force in the rod changes from tension to what, guys, compression. Okay, tension from tension to what, guys, compression, to just you can say balance out the what, centripetal condition. Okay, to balance out the what, guys, centripetal condition, you can say. And at the end, what will happen, the velocity becomes zero. And guys, because the downward pull is continuously acting on the block, it will pull down again, and the rod can't change its shape. So guys, the particle will what, come down, and it will perform this kind of a circle, guys. So I hope you understood this idea also, guys. Now the similar scenario, guys, the similar scenario, okay, the similar scenario you can have, the similar scenario, guys, you can have the same that we have studied for the rod plus what, this uh, block thing. Okay, if guys you have a ring, this kind of a thing, and here you have some bead. Okay, here guys you have some bead, then this bead is also what, is constrained to move like a what, this this particle which is attached to the rod, guys. If you see, if anyhow it reaches to this topmost point, guys, if velocity becomes zero, it will come back down. Okay, it can't go up, and it can't do projectile because it is constrained to what, to move on this path only, or you can say on this ring only. So it is very much what, similar to what, this case. Okay, so guys, if ring plus bead condition comes in front of you, you can treat the analysis just like what we have done for the what, rod plus block case. Because see guys, if you see this bead, if it reaches on the topmost point and is having just 0 plus velocity, guys, automatically it will slide down it, and it will what, come to the bottom. Okay, so it will be able to perform the full circle. So guys, this and this are what, guys, you can say a kind of a what, in the terms of physics, just the physical picture is what, guys, different, but the mathematical aspect is what, still the same. Okay, so just physical representation has been changed, but guys, the mathematical aspects are, or the physics aspect is what, guys, still the same. So they are both are what, guys, you can say in terms of physics or in terms of maths is what, equivalent. Okay, there is nothing different from in nothing different in both the cases. Okay guys, so I have covered, guys, all the possible scenarios that we may encounter in the different modules, or as a problems in the different scenarios. Okay, now in terms of theory we have covered the vertical circular motion. Now I'll take in the next lecture some very good problems, and we will see some very good thought-provoking concepts also in as a problem. Okay, in the next lecture. Okay guys, so